Okay, so this is our second part of the lecture on solid, toxic, and hazardous waste. So this is part two. Part one, we talked about the difference between municipal and industrial waste, what we call the waste stream, and then some challenges with the method of disposal of waste. We talked about open dumps, e-waste, sanitary landfill. Something to mention, I want to back up just one small step. On the sanitary landfill, a positive of the sanitary landfill, is that we are recognizing the value of this, and actually, let me get the marker, and once this is covered up, so okay, this is supposed to be covered now. You got all this stuff underneath it, rotting, decomposing, some of it never going anywhere. One of the things that's being done is we are actually capturing the methane. So there's supposed to be a vent pipe there, and capturing the methane and using the methane for heating. We call it flaring, when they usually just burn it off, where now we're recognizing methane, natural gas, let's use this stuff. Why waste it? Why burn it and throw it away? But that is one of the positives of the sanitary landfill method of waste disposal. And then again, we left off with incineration or energy recovery. You're burning the garbage, you're reducing the volume. Usually this can be anywhere 80 to 90% reduction in volume. You're producing heat for heating or electrical generation. And then you have a smaller volume of waste to deal with. Again, the negative here, particulates, some of the pollutants produced during the combustion process when you're burning it can be a problem. You still have waste to deal with. Granted, a much smaller volume. Ideal scenario here is if we could separate the waste stream and we recognize certain things should be incinerated, other things should not. That's the biggest challenge, separation of that waste stream. Okay, so that's what we'll talk about as we get into our next part here, is really it's shrinking the waste stream. Let's see, how can we reduce this instead of worrying about separating? Reduce it first, then we move to separation. So reusing of products is absolutely the best thing all of us can do personally. When we buy something, can we reuse that product over and over and over and over? You do that, you're making a significant difference compared to even recycling or anything else. So let's put the big star and the happy face next to reusing. You get that water bottle, reusable water bottle. You fill it up 3 times a day for an entire year. Think about how many plastic bottles you just saved from going into a landfill, how much waste you didn't produce. Now, if we can't reuse, can we recycle those products? So we do grab that water bottle out of the vending machine, or the bottle of Pepsi or whatever. I'm not saying we're not going to, but if we can reduce the number of times, when we do buy those things, can we then recycle them and make sure they go in the correct recycling bin and that the product then gets reprocessed into a new product? So consider all of the things down here that are recycled on this graph. So automotive batteries, almost 100% recycled, because by law, you have to recycle it when you buy a new one. So if your car battery dies and you get it replaced, you're charged a recycling fee. The mechanic takes your bad battery, recycles it, gives you your new one. That tends to encourage recycling. But you look at other things like steel, paper, aluminum, tires, etc. A lot of these things are not recycled. Our percentages, unfortunately, are very, very low. Glass, why are we only down to maybe 28% of the glass products that we use recycled? The goal is increasing all of these, increasing the amount of recycling on every single one of these to where we're not using raw materials. We're not extracting ore to make aluminum cans. Instead, we're recycling it. Paper, cardboard, paperboard. Why aren't we recycling greater amounts? So we'll talk about those challenges as we're going through this unit. And that is one of the, again, reducing, reusing, then recycling. That's how we shrink the waste stream. It's not by Separating it, that's helpful, but that doesn't reduce the volume when you just separate. So plastic, all of us use it. It's everywhere. Why can't we recycle more of this? So here's a challenge. Plastic recycling is great. You take that water bottle, you drop it in a recycling bin, it gets recycled. It can actually get turned into carpet, fleece clothing, different packaging materials, etc. They take the plastic, melt it down, reformulate it, or refabricate, if you want to call it that, into these new products. But the problem is, public policy favors new production of plastics versus recycled. You would think recycling would be economically cheaper than grabbing new petroleum and making brand new plastic. It's not, because policy, economics, public perception, etc., favors, well, let's just buy oil. It's cheaper. Let's get petroleum, have that turned into new plastic instead of recycling the plastic that we have and making that cheaper. It takes support and subsidies to make this economically viable, and we don't have that at this current time. So the support goes up and down based on the economy, as well as public opinion, as well as politics. Now, this is the big picture of what's going on with most of our municipal waste. We're seeing in the 80s and the 90s, we're seeing a greater increase in what is recovered for recycling, which is fantastic. So, we're recovering more, we're recycling more, we're composting more, we're combusting some of this into energy recovery. But the problem is, look at where we're still at with what's being produced. I mean, we're at over 250 million tons of waste production here. This is the problem. You look at that number. But consider what's happened with the human population in the last 50 years. It's gone up, which means more waste production. So we have to be very conscious of this. As the population goes up, we're going to produce more waste. We need to make sure we're finding better ways to dispose of that or reduce the amount of waste produced. All right, so composting. Composting is a great way to reduce the waste stream. What we're trying to do is encourage more people to compost your yard waste at the municipal level. Yard waste, about 12, maybe 14% of that waste stream. All this can be composted. Now the challenge, totally understand it. The challenge is you live in town, you get all these leaves in your backyard. What do you do with them? Well, let's bag them up. Let's bag them up, rake those leaves, bag them up, and then they go to hopefully a recycling center where those leaves can get ground down into mulch, and then the center sells the mulch. People use the mulch in the spring for their flower beds. It's a great way to recycle a natural product. The other option is when we're composting, can we convert it into biogas? So in town, in our backyards, it's not always that practical, but can we get composters that we basically fill up with all of our compostable material? And this is yard waste. This could be kitchen scraps, vegetable products. We don't want to be throwing meat and things like that in there, bones. Those take forever. And then you put a bunch of worms in there, and these are supposed to be your little worms, and you turn this and you rotate this every so often, and they basically digest it all down into rich organic soil. The other method with the composting, this is on the larger municipal scale, is when this stuff gets capped, they put in a vent pipe, and this starts producing methane. So there's our little methane flare. So let's make gas out of it. Biogas is what we're calling it here. So composting is great if we have the ability to do it and the resources. If nothing else, at least let's bag up our leaves and our yard waste and get that to a recycling center. In Springfield, it's free if you do it during certain times of the year. If you're out of season, then there's an expense to it. There's an expense to the bags, but if you have a trash can, you can put it in a trash can and just keep reusing your trash can. So it's a minimal expense, if any, And it's definitely a great thing to pull out of that waste stream and get it to the correct location. So separating the waste stream is going to be a key. Now, another big thing, and hopefully we're all part of this, is demanufacturing. So we have these appliances and electronics that go obsolete so fast. Think about the laptop you're using. How many have you had in your lifetime? How many cell phones? How many refrigerators? How many TVs, et cetera, et cetera, et cetera? These things go obsolete so quickly that we buy a new one. What do we do with the old one? Well, instead of just dumping it in a landfill, can we demanufacture it? Take it to a recycling center. Again, if you're in Springfield, taking your laptops in, taking your computers in, usually doesn't cost anything. A lot of times, organizations will have recycling events where they take things for free. Costs you nothing to get rid of this. And then they take these products, and they call it demanufacture them, basically disassemble them. A PC, the components inside the computer you're looking at right now will contain lead and different heavy metals. That goes to the landfill. That stuff leaches out, goes into the water system. Now you got an environmental problem. There's actually $6 worth of gold, $5 worth of copper, and $1 worth of silver in most PCs because you need those metals to produce the components of the PC. So this is why you take this in, it gets demanufactured. Do some math. BLH Electronics, if they take in 100 PCs a month times $6, that's $600 worth of gold, $500 worth of copper, $100 worth of silver. Across 100 PCs, they're looking at $1,200 worth of metals that they can pull out of that. Not a bad chunk of profit. So we want to encourage that. I'm more than happy to give them my old PC and let them make $12 off of it by demanufacturing it if I don't have to throw it into the landfill and it gets broken down correctly, repurposed, etc. So again, things to think about. Again, how do we shrink the waste stream? Reusing is, again, the most environmentally friendly thing to do. We want to reuse, reuse, reuse. Then we reduce. Simply produce less, use less, reduce the amount. Do you need a water bottle every day? A plastic bottle out of the vending machine? Can we recycle those things? Can I keep reusing my bottle day after day after day? Eventually it's going to wear out, but you get a year out of it, that's hundreds of bottles that have not gone to the landfill or possibly gone to recycling. If you do have to buy new ones, let's at least recycle those instead of just throwing them away. Packaging. Can we decrease it? How much unnecessary packaging do we get? I don't know about you guys, but go to a grocery store or go to anywhere, buy something, walk in running, okay, I'm going to grab one or two things, and they want to shove it into a plastic bag. Why? Convenience, ease. I can carry out two items in my hands as easy as I can carry out a plastic bag. Tell them no thank you. I don't want to waste it. I don't need that plastic bag. You do that a couple times a week, across the month, across the year, it makes a big difference. The other thing that we're talking about is, can we increase the use of photodegradable and biodegradable plastics? Now, photodegradable, I'm going to give this kind of this, we're not sure if it's a smiley face or a frowny face. Photodegradable is plastic that just breaks down into smaller and smaller and smaller pieces when it's exposed to light. Sounds good, but big picture, it doesn't disappear. It just breaks down. It just gets smaller and smaller. It's not going away. Biodegradable. This is what we want to put the smiley face on. Biodegradable plastics are usually made with cornstarch, which means they're organic and something's going to decompose them. Bacteria, fungus, detritivores, etc. can actually decompose that and break it down and reduce it to nothing. Those are the type of plastics we want to start looking for versus photodegradable. All right, so again, the big goal, can we shrink the waste stream? That is our goal here, is how to reduce and shrink that waste stream. All right.